Welcome to Arithmetic versus Geometric Sequences. A sequence is just a list of numbers. So hopefully we remember that the terms of a sequence can be listed with subscripts, where a sub 1 is the first term in the sequence, a sub 2 is the second term, a sub 5 would be the fifth term, and so on. Now, let's say we have the sequence 8, 5, 2, -1, and -4. That means 8 is a sub 1 because it stands for your first term. 5 is a sub 2, your second term, a sub 3, a sub 4, and a sub 5 as our fifth term. Please make sure that the 1, 2, 3, 4, and 5 are actually written as subscripts, because if you write A with a large one, that's not correct. So please don't do that. Now I know this problem's asking for the common difference, and we're going to explain that later on in the video, but for now let's just think of that as your pattern. And the pattern in this case is that you are subtracting 3 each and every time. You want to be careful and make sure that that pattern works for every single term, because a lot of the times the Regents likes to make it work for the first one and maybe even the second one, but then for the third one it might not work. So just double check to make sure that your pattern works for everything. So let's look at this sequence now. We have a sub 1, your first term, a sub 2, a sub 3, a sub 4, and a sub 5. Sub just stands for subscript. Now, maybe you found the pattern in this sequence, and the pattern is that each time you are adding 4. And the adding 4 works for everything. So the pattern is in words is adding 4 each time. Now, if you go and you graph this, you want to make coordinates. We're going to have n, which is our term number. And we're going to have a sub n, which is the actual value of the term. So our first term, a sub 1, was 3. Our second term, a sub 2, was 7. A sub 3 was 11. Our fourth term was 15, and the fifth term was 19. Notice how we're starting at a sub 1 and not a sub 0. Sometimes they'll give you a problem where they'll say a sub 0, but anytime that you have to write it, we're going to use a sub 1, our first term. Take a minute, actually plot it out on your graph. And here's the graph that I got when I had a scale counting by 1 in each direction. Now, you do not want to connect the points, and the reason is that you have the first term and the second term. There's no term and a half. There's no term 1.7. Do you know what I mean? There's nothing in between the first and the second term. There's nothing in between the second and the third term. So it doesn't make sense to put lines showing that there's values in between them. We're always going to leave sequences as plotted points. And what do you notice about the graph? If you were to connect them, they do form a linear equation. So the graph is linear. Now, this particular sequence is called an arithmetic sequence. Arithmetic sequences uses the operations of addition and subtraction. Arithmetic sequences have a common difference, like we mentioned before. Arithmetic sequences are modeled by linear functions when we just plotted it on the graph. And arithmetic sequences have a constant rate of change, right? Because linear functions have a constant slope. If you look at the problem before, the 3, 7, 11, 15, and 19, we call it a common difference because if you do 7 minus 3, you get 4. If you do 11 minus 7, you get 4. 15 minus 11, 4. 19 minus 15, 4. And that's where the common difference is actually coming into play. The way I like to remember it is that arithmetic sequences are A for adding. Now, there is a formula associated with arithmetic sequences. It's called the explicit formula. Now, the explicit formula can be used to find missing information, and it could also be used to find the nth term, and that's important. So, if you see a sub n, that represents the nth term. A sub 1 is your first term. N is your term number. And D is your common difference. We're going to go over how to use this formula in class. But it is helpful to know that you do not need to remember this formula because it's on your reference sheet. You just need to know how to use it. Now let's look at another sequence. Again, we have a sub 1, a sub 2, a sub 3, and a sub 4 for our first, second, third, and fourth term. Now the pattern in this case isn't adding, because at first you add 3, but then you add 6, and then you add 12. The pattern in this case is multiplying by 2. And it works each and every time. Now when you go and you graph this one, it's going to be very similar to how we graphed the last one, right? You have your term number and your term value. We have 1, 2, 3, 4, and our values were 3, 6, 12, and 24. When you plot this out, this graph, it's too much to count by 1 each direction. You could count by 1s for your x-axis, but for your y-axis, you're going to have to count by 2s in order to get everything on the grid. And what do you notice about this graph? Is that if you were to connect it, it looks like a curve, right? Because it looks exponential. We're not connecting it for the same reason as before. There's nothing in between the first and the second term. But look how when you do connect it, it's not linear at all. So this sequence is called a geometric sequence. Geometric sequences use the operations of multiplying and dividing. Geometric sequences have a common ratio. They are modeled by exponential functions, and they have a percent rate of change because exponential functions, you're increasing by 20% or you're decreasing by 30%. The reason, if we go back to this formula, sequence is 3, 6, 12, 24, and so on. The reason why it's called a common ratio is if you divide 6 divided by 3, that ratio is 2. 12 divided by 6, that ratio is 2. 24 divided by 12, that ratio is always 2. So there is an explicit formula for a geometric sequence, and it can be used to find missing information as well. It's pretty much the same thing as before. A sub n is the nth term. For example, if they wanted the 5th term or the 6th term, you would have a sub 6 or a sub 5. A sub 1 is your first term. R is your common ratio, and N is your term number. This formula is also on your reference sheet. You do not need to remember it. So just keep in mind as a good sum it up, you have 2 types of sequences. You have arithmetic And you have geometric. Arithmetic is adding and subtracting. Geometric is multiplying and dividing. One has a common difference d, the other one has a common ratio r. Now, they both have explicit formulas. So the explicit formula for both of them, the first one would be a sub n is equal to a sub 1 plus n minus 1 times d. The explicit formula for the second one is a sub n equals a sub 1 times r to the n minus 1. Now, when you actually do problems with these, first of all, you have to make sure, is your sequence arithmetic or geometric? And then, additionally, you have to make sure of what type of equation do they want this in, because there is something other than an explicit formula, which will be mentioned in a next video. It's called recursive form. So make sure if the question's asking for explicit or recursive that we're going to see later on. It's explicit if you need to find a particular term number. If you want to find the 10th term or the 100th term, you're going to use explicit. If it's asking you for the nth term, you're still going to use explicit. But there is an explicit formula for both arithmetic and a separate one for geometric. And that's all for this video.